right, welcome to another moment of science. Today we are talking about magnets. Here we have a regular bar magnet. You can see it's marked with an N and an S for its north pole and its south pole. So the first question you have on your Google document is to draw and label one magnet. Anytime you need to, you can pause this video to answer the questions in the Google document, but you're going to be seeing these things happen in order. So when you have two magnets together, you will see that they will only attract in certain ways. So you can see that those two just attracted each other in this way. So this can be your first drawing of when two magnets attract each other. Okay. Now, your next question is going to be, are there any other ways for these two to set up and be attracted? Okay, so take your magnet drawings. Would they attract this way? Would they attract this way? Would they attract when they're up and down? Would they attract when they're at an angle? Whatever you think will be. You should have at least 3 to 4 answers for different ways that these two magnets could attract each other. So do remember that magnets only attract each other when they are facing the opposite poles. After you get done with that, we're going to show you two magnets repelling each other. When you try to put the same poles next to each other, they will repel each other. And you will actually see one move away from the other. They do not like to attract each other when this is happening. Okay, so that can be your first drawing of two magnets repelling each other. Then you're going to do the same thing. You're going to say, is this the only way that they will repel each other? And then you're going to draw the 3 to 4 different drawings of these two magnets repelling each other in different situations, not just this one, but in other situations. Would they repel each other like this? Would they repel each other like this? Would they repel each other like this? Or like this? Or like this? Okay, so draw your 3 or 4 different sets of magnets so that can happen. Okay. Now, the last question on the first page is, what is a magnetic field? And I'll give you a good example of seeing that magnetic field in action. You saw it right there. Okay. I'm not going to tell you exactly what you saw, but hopefully you saw it happen. Okay, so what is a magnetic field? Now we're going to get to the cool part. This is my favorite, one of my favorite labs of the year, and I'm so bummed that you guys aren't going to get to do it. But if you have a bar magnet and some iron dust around your house and you have your parents' permission, I would definitely suggest doing this lab. Okay, so what I'm going to do is I'm put one bar magnet underneath the index card. And I've got my container of iron filing, or iron dust. And I'm going to sprinkle this on top of the magnet. And we're going to see what happens. Can you see what happened? Can you see the magnet underneath the card? What you're going to do is you're going to draw what you see after I sprinkled it. Okay, I know this can be a little bit difficult to draw, but I want you to try your best to draw what you see on this card. And then question number 10 asks you, what is the iron powder showing you? Okay, if you notice, you can see some curves here in the iron. You can also see iron sticking up here and iron sticking up here. What is that showing you? Why can't you normally see that? When I look at a magnet by itself, why can't I normally see what I see on this card? And finally, why do I use iron powder or iron dust to take a look at this? Why can't I use something else? So that is what one magnet looks like with iron dust around it. So I'm going to take this off. You can see once I get it away from the magnet, it all goes back to normal. Now, I'm going to put two magnets together. Okay. I'm going to show you what would happen in this case when I pour iron dust in it. You'll see something slightly different. Okay. After I do this, you're going to draw what you see, and you're going to tell me what evidence you see that the magnets are attracted to each other. I know they are, but I want to see what evidence do we have that they're actually attracted to each other. Okay. I'm going to do that one more time because that one didn't go as well as I could. Remember, that's the great thing about science. You can always retry yourself. Working out much better. Okay. All right, so take a look at that. Draw it and tell me what evidence do you have that the two magnets are actually touching and attracting one another. All right, and then the final one. I'm going to set up two magnets repelling each other. I'm going to set them as close as they can be without actually touching or pushing away from each other, because if I get too close, again, it will push away. But actually, when I'm moving them together, I can actually feel the force trying to push against me. Right, so we got those set up right there. We're going to see if we see anything different compared to the other one that we just did with them attracting. So same thing, you're going to draw what you see, and you're going to give me evidence that these magnets are repelling each other. Even better than the last one. Now, take a look at this. You should see one big difference between this set of magnets and the two magnets that were attracting each other. So again, draw what you see and give me evidence for why you know that these two magnets are repelling each other. After you have done all of that, you have two conclusion questions at the bottom of the document. Do magnets have a limit to how far their effect goes out from them? Make sure you give evidence from this activity to prove your conclusion. And then number 14, just like gravity and electric force, two things affect the strength of a magnet's force. What are they? All right. Thank you so much for joining me for another moment of science. The next one will be involving electricity and magnetism at the same time. Enjoy your day.